There are three reciprocal trigonometric functions added to the one we already know: the sine, the cosine, and the tangent, making a total of 6. When we have this right angle triangle A, B, and C, which is right angled at point B, let angle C be equal to theta. The place facing theta is called the opposite, which is small letter c, while the place facing B is the hypotenuse, which is small letter b, okay, while the other end facing A is called the adjacent, which is small letter a. So to find our angles, we can use the acronym, which is SECANT, like we discussed in the last series. We can use this acronym SECANT to find the angles. Now the sine, which is the SO, is equal to opposite over hypotenuse. So based on this right angle triangle, sine theta, our opposite for sine theta is our small letter c, while our hypotenuse is the longest side, which is small letter b. So our sine theta is equal to opposite over hypotenuse, which is c over b. Let's briefly look at the reciprocal functions. The reciprocal of sine function is cosecant. Cosec theta or cosecant theta is equal to the inverse of sine theta, which is 1 over sine theta. So please note this: cosec theta is always equal to 1 over sine theta. Now, what is sine theta? If we are applying the acronym SECANT, sine will be equal to opposite over hypotenuse. Okay, opposite over hypotenuse. Now, if we are substituting, it becomes 1 over opposite over hypotenuse. Okay, since sine is equal to opposite over hypotenuse, so anywhere we see sine theta, we replace sine theta here with opposite over hypotenuse. So it becomes 1 over opposite over hypotenuse. And our opposite is c, while the hypotenuse is b. So it becomes c over b. So we have established the fact that opposite over hypotenuse is equal to c over b. So we substitute. Anywhere we see opposite over hypotenuse, we put c over b. Okay, so now it becomes 1 over c over b. And this is the same thing as saying 1 divided by c over b. This is division. So 1 divided by c over b. So if I'm to change this division to multiplication, I will find the inverse. B comes up, c comes down. So it becomes 1 times b over c. So b over c times 1 is equal to b over c. So cosec theta is equal to b over c. So have you seen that cosec theta is the inverse of sine theta? Sine theta is c over b, while cosec theta is b over c. So this is the inverse of this. I also want you to know that the reciprocal of cosine function is secant. The reciprocal of cosine function is secant. What do we mean? Let's explain what we mean by this. In this right angle triangle, how do we get cosine theta? Based on the acronym we have been working with, SECANT, cosine theta is equal to adjacent over hypotenuse. So here is the adjacent, here is the hypotenuse, which is A over B. So what if we were asked to find secant theta? We are told that secant theta is equal to 1 over cos theta. Okay, 1 over cos theta. But we know cos theta to be adjacent over hypotenuse. What is our adjacent? Our A. Hypotenuse is our B. So we can substitute into this. We will have 1 over A over B, isn't it? Because cos theta is A over B. So this and this, they are the same. 1 divided by A over B. If I want to change this division sign to multiplication, what will I do? I find the inverse of A over B, which is B over A. So B over A times 1 is equal to B over A. That means secant theta is equal to B over A. Now look at this. We said secant theta is equal to the inverse of cos theta. Now we have gotten secant theta to be B over A. Our cosine theta is A over B. Have you seen that this value we have gotten is the inverse of this value? Okay, so the inverse of A over B is B over A. So we have established the fact that secant theta is equal to inverse of cos theta. The reciprocal of tan theta is cotangent. The reciprocal of tan theta is cotangent, and it is expressed as cot theta is equal to 1 over tan theta, or cot theta is equal to cos theta over sine theta. Whichever one you want to use, you will still arrive at the same result. Let's watch. Now, having this right angled triangle, we can say cot theta is equal to 1 over tan theta, or cot theta is equal to cos theta over sine theta. So the values for cot theta is either 1 over tan theta or cos theta over sine theta. Now, since we have this, what is tan theta? What is tan theta? Using the acronym SOCATUA, tan theta is equals to opposite over adjacent. Okay, that's the TUA. Tan theta is equal to opposite over adjacent. Now, that means if this is opposite over adjacent, we are going to substitute opposite over adjacent for tan in place of tan. We are going to substitute opposite over adjacent in place of tan. Remember, we want to simplify 1 over tan theta. So this becomes 1 over opposite over adjacent. 1 over opposite over adjacent. So opposite over adjacent, this is the same as this, okay? If I'm changing this division sign to multiplication, I find the inverse, so it becomes adjacent over opposite. And what's our adjacent over opposite based on this right angle triangle? It is A over C. So please take note that cot theta is the same as A over C. Now let us look at cos theta over sine theta. Let's see if cos theta over sine theta is the same thing as 1 over tan theta. We all know that cot theta is equal to cos theta over sine theta. Cot theta is equal to cos theta over sine theta. Now, what is cos theta? Cos theta is adjacent over hypotenuse, while sine theta is opposite over hypotenuse. So if we are having cos theta over sine theta, we replace it. Cos theta is adjacent over hypotenuse divided by sine theta is opposite over hypotenuse. Now, what is our adjacent? Our adjacent based on this right angle triangle is A. Adjacent is A. hypotenuse is B, that's A over B, divided by our opposite is what? C, while our hypotenuse is B divided by C over B. Now, if I want to change this to multiplication, I find the inverse of C over B, which is B over C. So B can cancel out B, remaining A over C. So we are having A over C as the final solution. A over C is the final solution. Now, if A over C is the final answer here, that means this value is equal to this value. Are you seeing it? That means 1 over tan theta is the same thing with cos theta over sine theta. They are the same. So therefore, we can say cot theta is equal to 1 over tan theta, or cot theta is equal to cos theta over sine theta. Let's take this relevant example. If tan theta is equal to 5 over 12 and 0 is less than theta less than 90 degrees, find question 1 sine theta square or sine squared theta, 2 cos theta minus sine theta, 3 cosec theta, and 4 secant theta. Let's see how we can solve this problem. We are asked to find sine squared theta. Now, the first thing we are going to do is to substitute 5 over 12 in this right angle triangle. What is 5? What is 12? Now, to know what these two things is all about, we need to apply SECANT. Now, applying SECANT, our tan theta is equal to opposite over adjacent. That means our opposite is 5, adjacent is 12. Where is our opposite? Anywhere theta is facing in this right angle triangle is our opposite, which is 5. The other part is our adjacent, which is 12. So this part here is our adjacent, which is 12. Then the longest side of the right angle triangle is our hypotenuse. We don't know hypotenuse, so we replace it with x. Before we can start solving for this problem, we need to find the hypotenuse of this right angle triangle. How do we get the longest side in a right angle triangle? Remember, when you are looking for the longest side in the right angle triangle, you square the other two sides and you add them up. What do we mean? To get our x, what we do is to apply the Pythagoras theorem that states that hypotenuse squared is equal to adjacent squared plus opposite squared. Okay, hypotenuse squared is equal to adjacent squared plus opposite squared, or opposite squared plus adjacent squared. Whichever one you want to do is still the same. Now, what is our opposite? Our opposite is 5. That's 5 squared. Adjacent is 12. That's 12 squared. So 5 squared is 25. 12 squared is 144. If you add these two up, you get 169. Now, to get the hypotenuse, which is the x, you find the square root of both sides. So square root of hypotenuse squared equal to square root of 169, and the final answer is equal to 13. That means our hypotenuse is equal to 13. Since we have gotten our hypotenuse to be 13, the next thing to do is to solve for sine squared theta. Now, what is our sine based on SECANT? Sine is equal to SO, which is opposite over hypotenuse. Okay, sine is equal to SO, which is opposite over hypotenuse. Now, what is our opposite here? Opposite is 5. Hypotenuse is our x, which is x is equal to 13. We have found our x to be 13, so we substitute. So it becomes 5 over 13. So because of this square here, we are going to square this. So 5 squared is 25. 13 squared is 169. So sine squared theta is equal to 25 over 169. Question 2, how do we find cos theta minus sin theta? The first thing we will note is that cos theta is the curve which is adjacent over hypotenuse. Adjacent over hypotenuse. So cos theta is the curve which is adjacent over hypotenuse. Now, if cos theta is equal to adjacent over hypotenuse, we know that our adjacent is equal to 12, hypotenuse is equal to 13. We know that cos theta is 12 over 13. So what is our sin theta? So simply means opposite over hypotenuse. Our opposite here is 5, hypotenuse is 13. So we have known our cos theta and sin theta. Let us substitute into this equation. So in substituting, anywhere we see cos theta here, we put 12 over 13. Anywhere we see sin theta, we put 5 over 13. So we have 12 over 13 minus 5 over 13. So since the denominators are the same, we pick 1 and we subtract the numerator. So 12 minus 5 is 7. So cos theta minus sin theta is equal to 7 over 13. Number 3, to find cosec theta, we all know that cosec theta is equal to 1 over sin theta. Now, what is sin theta? Sin theta is opposite over hypotenuse, which is 5 over 13. So substituting 5 over 13 into this equation, so it becomes 1 divided by 5 over 13, which is the same thing as 1 times 13 over 5, because if I want to change this division sign to multiplication, I find the inverse, so it becomes 13 over 5. So 1 times 13 over 5 is equal to 13 over 5. So cosec theta is equal to 13 over 5. The last example, we are asked to find secant theta. So what is secant theta? Secant theta is equal to 1 over cos theta. And we know that our cos theta is equal to adjacent over hypotenuse, which is 12 over 13. So substituting into this, we are having 1 divided by 12 over 13. If I want to change this division sign to multiplication, I find the inverse, which is 13 over 12. So 13 over 12 times 1 is 13 over 12. So secant theta is equal to 13 over 12. Please pause this video and solve the following. If cos x is equal to 5 over 13, find the value of sin x and tan x. In our next series, we will be looking at complementary angles.